Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video I am going to talk about steam distillations, the isolation of limonene. Important terms. What is the terpene? A compound whose carbon skeleton can be divided into two or more units, identical with the carbon skeleton of isoprene. Isoprene, 5 carbon compound with a specific skeleton structure. Limonene, you can see the structure of limonene. So, what is the overview of this lab? Peel a large orange or two and remove the pith. Grind the peel in a blender containing distilled water until a uniform slurry is obtained. Distill an essential oil called limonene from the resulting solution. Isolate the limonene using the liquid extraction and characterize the limonene using gas chromatography. Now, what is the distillation? Distillation is the process of heating a liquid until it's boiled, capturing and cooling the resultant hot vapors, and then collecting the condensed vapors. Technique has been used for thousands of years back. Why are distillation used? Identification of a compound's boiling point. Important physical properties of any compound can be used to help identify an unknown compound. Purification of a compound by separating it from a non-volatile or less volatile material. How do distillations work? A mixture is heated to the boiling point of the more volatile compound. Lower boiling point, this compound becomes a vapor and can be collected from the heating chamber and condensed back into a liquid. Look at this setup. Now, distilling technique to separate liquids based on their boiling points. Refluxing, boiling, the boiling of liquid at its boiling point. Round bottom flask, self-explanatory. Condenser, jacketed glass tube to allow cold water to pass through it and condense the vapor. Fodiran, the first substance to distill over. Distillate, the substance collected from the distillation. And pot residue, the substance left over in boiling flask. Now, steam distillations. A special type of distillation used for materials that are sensitive to high temperature. Many organic compounds like natural aromatic compound decompose at high sustained temperatures, so cannot be separated by normal distillation. Addition of water vapor into apparatus can allow for lower temperatures. Limonene boiling point is 176 degrees Celsius, but it will boil at a temperature close to 100 degrees Celsius using a steam distillation. Now friends, what is boiling point? Temperature at which something boils, yes, but that's not all of it. Boiling occurs when the vapor pressure of the liquid becomes equal to the pressure of the external pressure of its external pressure. Vapor pressure. Think of boiling point, boiling water at high elevation. Vapor pressure of different liquid. The vapor pressure of a liquid is principally determined by the strength of the intermolecular forces of the liquid. Liquid in which the intermolecular forces are strong have relatively low vapor pressure and high boiling point. Now, vapor pressure and temperature. Vapor pressure increases significantly with temperature. Distribution of thermal energy. Temperature dependence of vapor pressure. Vaporization requires input of energy to overcome the intermolecular attraction between molecules. Only a small fraction of molecules in a liquid have enough kinetic energy to escape. By increasing the temperature, the fractions of molecules with escape energy or kinetic energy increase. The higher the temperature, the faster the rate of evaporation by the high energy molecules at the surface of the liquid. Now, vapor pressure increases with temperature. As a compound is heated, its vapor pressure increases rapidly. Normal boiling point temperature at which a liquid vapor pressure equals 180. Does water have higher or lower boiling point at higher elevation? Now you think things to do before the distillations. Add boiling chips to your orange and peel celery. Boiling chips work by providing nucleation side so the liquid boils smoothly without becoming superheated or pumping. Make sure the joints of your distillation apparatus are lubricated and sealed. Start flowing water through your condenser. Ask your TA to check your setup before starting the flow of water. Wrap your rounded bottom flask and distillations adapter with aluminum foil to prevent heat loss, and this will shorten the time it takes to complete the distillations. Things to do after finishing the distillations. After distillation, the round bottom flask must be removed from the heater completely. Just turning the heat off is not enough. The remaining water will be evaporated and pulp will be baked inside the flask and nearly impossible to get it out. Transfer the distillate into a 125 ml separatory funnel and stack the aqueous mixture twice using dichloromethane. Combine the dichloromethane extracts and dry them with sufficient amount of magnesium sulfate. Gravity filter the dichloromethane to remove the magnesium sulfate. Remove the dichloromethane using a rotary evaporator. Analyze the product by gas chromatography. Now, common organic solvent for extraction. Immiscible with water, density 0.9982 gram per ml. Hexane, density 0.6594, diethyl ether 0.7133, toluene 0.86669, organic layer on top, and ethyl acetate 0.9006, dichloromethane 1.326, organic layer on bottom. Immiscible with water, density 0.9982 gram per ml, ethanol 0.7892, acetone 0.7900, methanol 7913, tetrahydrofuran 0.888. So friend, what is vacuum distillation? Vacuum distillation is distillation at a reduced pressure. Since the boiling point of compound is lower at lower external pressure, the compound will not have to be heated to as high temperature in order for it to boil. Vacuum distillation is used to distill compounds that have a high boiling point or any compound which might undergo decompositions on heating at atmospheric pressure. The vacuum is provided either by water aspirator or by a mechanical pump. Now, rotary evaporator, commonly called rotavap, very commonly used, evaporates slow boiling solvent like DCM from solutions at reduced pressure. Higher boiling solute is left behind in evaporating flask. Example of vacuum distillations. You can see here, this is rotavapor. This is motor control. You see the heating, condenser, trap. Now you can see other pictures. Now gas chromatography, another separation method in which molecules either stick to the stationary phase or move with the mobile phase. Gas. Separation is done entirely in the gas phase. Separation is based on boiling point for molecules of similar polarity, usually used for analysis rather than preparative purifications. Friend, how does GC work? This is the carrier gas, flow controller, injection pot, vacuum oven. You see the column, this detector and recorder. 4 component: an injection pot, a column inside the oven, carrier gas and a detector. Injection pot, where the sample is injected with microsyringe, heated so that the sample is immediately vaporized. A heated cavity that keeps compound in the gas phase. GC column is coated with the stationary phase that separates the compounds. No interaction with other compounds. Respond to the thermal conductivity or ionization detector. Now, the heart of the system. You see the carrier gas, flow control, injection pot, column oven, detector. Commonly stationary phase are cyanopropyl phenyl dimethyl polysiloxanes, carboxylic polyethylene glycol, bis cyanopropyl phenyl polysiloxanes, diphenyl dimethyl polysiloxanes. We will be using a standard non-polar GC column. So what is detector? Visualizations. Concentration dependent detector detect the concentration of solute. Now, factors that affect the GC separations. Factors that affect retention time on standard non-polar GC column. Volatility of the compound, boiling point, higher BP, longer retention time. Higher BP, longer retention time. I repeat, higher BP, longer retention time. Carrier gas flow rate and temperature. Lower temperature and flow rate, longer retention time. Varying these parameters can improve separation. Length of column, longer retention time. Longer column, longer retention time. Now, injection of limonene into the GC. Remove the dichloromethane with rotatory evaporator and dissolve the residue in 0.5 ml of dichloromethane. Show your dilute sample to your TA, who will check for dryness. Stock room attendant or TA will inject 1 microliter onto the GAC, means gas chromatography. Check that you are happy with the results. You may have to re-inject another sample. You can see this is two peak, compound with lower boiling point and compound with higher boiling point. First compound to elute has a lower retention time. Major component of mixture should have a large area under the curve. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.